Welcome back to my YouTube channel, and in today's video I will be explaining differentiation in bits. So first of all, what is differentiation? In order to understand what differentiation is, so let's say we have a graph of x to y, this to x and this to y, and then we have a linear equation, something that goes this way. So differentiation is the slope of a graph. Differentiation is known as the slope of a graph. So here we will have, this is our y2, this is our y1, this is our x2, and this is our x1. So this is what differentiation is all about. So if we were to find for the slope of this graph in normal mathematics, we will have y2 minus y1 all over x2 minus x1. So the differentiation of a slope, the differentiation of an equation is known as the change in y over the change in x, limits where change in x tends to 0. That is what differentiation is. But that is not where we are going. Now we are going to be doing some basic differentiation here. Let's say we have y is equals to x square plus let's say we have y is equals to x square. How do we differentiate this? First of all, you have to take note of the formula. When y is equals to x raised power n, then the y, the x is equals to this n, which is the power of x, multiplied by everything, n times x raised power n. Then you now remove 1 from the power of x, that is n minus 1. Now this is the formula for differentiation. So let's say we have y is equals to x squared. What do we just do? We find for the power of x squared. The power of x here, is 2, right? So we multiply the whole equation by 2. So we have our dy dx is equals to, this here will be 2 times, we come back, we write our x squared, then we remove 1 from the power that we have, that is 2 minus 1. So when we multiply this together, we have 2 times x, 2 minus 1 is equals to 1, that is x is power 1. So when we simplify it, we have 2x as our final answer for dy dx. So this is how to differentiate something. Now let's go a little bit further. Let's say we have something like y is equals to x squared plus x plus 1, something like this. So how do we differentiate this? We differentiate this different, differentiate this different, and differentiate this different. So we get our dy dx is equals to our x squared. We differentiate it. We find for the power of x squared, which is 2, right? So we have 2 multiplied by everything here. We have 2 times, then we have our x squared. This is x squared. Then we remove 1 from the power, minus 1, this is it, plus our x. Now if we find for the power of x, x is raised power 1. X raised power 1 is the same thing as x. So here we are having 1 times x raised power 1 minus 1. So if we are to simplify this, that is for this place, then we now have for 1 here. So Simply, you must have already heard that whenever you see a constant, the differential of a constant is equals to 0. It's automatically 0. That is plus 0. But how did they get 0? I will explain this for you. So we all know that anything raised power 0 is 1. If we have x raised power 0 is equals to 1. Anything raised power 0 is 1. So that means we can have our 1 here as x raised power 0. We have it as 1 times x raised power 0. Because if we try to simplify this, we still have something like 1 times, here we have 1, which will still be equals to 1. So we can write it this way as 1 times x raised power 0. So our 1 times x raised power 0 here, how do we integrate 1 times x raised power 0? We have, when we are integrating this, we are going to be having, when 1 multiply this, will still give us the same thing, which is x raised power 0. When we are now differentiating it, we have the power here multiplied by everything. So 0 times 1 times x raised power 0. Then you now minus 1 from the power, which is minus 1. That is what happened in this place. So when we get everything together, we are going to get our final answer as 0. But let's go. We have here 2 times x raised power 2 minus 1 is x raised power 1, as we have gotten earlier. So we have 2 times x here, then plus here x raised power 1 minus 1. That is x raised power 0. And we know that x raised power 0, anything raised power 0 at all, is equals to 1. So we have here 1 times 1 plus this here. So then when we simplify it, we have 2 times x, it will be equals to 2x plus 1 times 1, we have 1. 0 times everything here will automatically give us 0. So we have our final answer here as 2x plus 1. This is our final answer. So now, what if we are given something like this? We have y equals to 1 over x plus 2, something like this. And they told us to find for the differential. They asked us to differentiate this. How do we go about it? First of all, when differentiating this, we can bring this x up using the law of indices that states that if we have 1 over x raised power n is the same thing as x raised power minus n, which most of us will mostly be familiar with. So we can write this as y is equals to x raised to power. We know that when we have x, it's still the same as x raised to power 1. So when it comes up, this will be x raised to power minus 1 then plus 2. So from here, we can continue our differentiation. We have the y dx is equals to, as I said earlier, y differentiating, the power you multiply by the whole integer. We have minus 1 times x raised power minus 1. Then you now remove 1 again, which is minus 1 minus 1. And we have plus these 2 here. Just like we solved earlier, whenever you see a constant, the differentiation and the answer will be equals to 0 automatically. So from here, we have e is equals to minus 1 times x raised power minus 1 minus 1. Now, minus 1 is equals to what? Equals to minus 2. So we have minus 1 times x raised power minus 2 plus 0, like that. So when we simplify this, we have minus x raised power minus 2. Then we can bring it back into the normal fraction method, which will not give us minus 1 over x squared. That is, when we are bringing this back to this particular form, we can get something like this. So this is the answer of this.